Hey Lama, this was a very long meeting. Can you please summarize it for me? Okay, that was way too specific. Please, everybody, just ignore that and just watch the video to see how we can build a cool conferencing tool with LLM integration and live transcriptions on your own. Hello and welcome to this video on building an AI-powered video conferencing app using Next.js, Stream, and AssemblyAI.
I'm Patrick from AssemblyAI, and together we will build upon a basic video conferencing app and add two AI features to it. The first one is going to be live transcriptions, so we show on screen what people are currently saying. And the second one is an LLM integration, where people can ask a large language model with their voice and then get a helpful response back that we also display in the app.
Now, we already put out a blog post on the AssemblyAI blog that demonstrates how to build this. And you can read this if you want. And we also have the repository shared, so all the code is public. But we thought for this video, we want to do one more thing and add a new feature. And that is going to be adding the history of the meeting. So everything that was said to the memory of the large language model. So with that, we can ask questions about the current meeting, what people were talking about, what topics were discussed, what decisions were made. We can ask it to summarize events and more. So we will add this feature in this video. So make sure you subscribe to the channel to see when new videos are popping up. And without further ado, let's get started by setting up the project. For setting up the project, we only have one prerequisite, and that is a Node version of 18.17 or later. So what we will do is we won't build everything from scratch, but we want to focus on building the AI features. So we will clone the repository. We have a starter project branch there to get started with a blank slate. And then we need to set up our credentials. So have the Stream credentials as well as the assembly credentials put into the project, and then we can run it and see what we have to start with. So let's jump into our browser. We can see we have the project here. I'll add the link to that in the description of the video, and we can hit the copy to clipboard here for cloning it. And we switch to our terminal and we clone this into a local folder. Then we cd into the project folder. We can already see the project has been set up. So what we will do is we will switch into the starter project folder. And from here, we can now open up VS Code to do everything else. So we switch to VS Code and we see the project is set up. We have a regular Next.js project with an app folder, and we can take a quick tour over that. But for now, we are interested in the env template file because this is one that we need to add ourselves. And we can already see we need three properties here. First is going to be the Stream API key, the Stream secret, and then the Assembly API key. So let's start off by creating a new file. We call it .env.local. And we copy over the values here into our env file. Let's close the sidebar. And I've copied it here. So we need to collect these values. And for that, we switch back to the browser. And we head over to dashboard.getstream.io, and here we see the Stream dashboard. You can sign up with a free account, and I'll add a link in the description of the video how to do this. And now we see here that we have an API key that we can copy and paste here, and we have a secret that we can also copy and paste. Don't worry, I will delete the project afterwards, so nice try stealing my secrets. And the last thing we need to do is add the AssemblyAI API key. And for that, we switch back to the browser and we go to the assembly page. Specifically, this is AssemblyAI.com. We can log in and then we see the dashboard here. And here we have an API key as well that we can copy and paste into the environment file as well. So with that, we can open up the terminal here inside VS Code and we can now first install the dependencies and then I'm using Yarn by the way, and then we can run the project using yarn dev or npm run dev, whatever you prefer. And we can see the project is running now. It's running on localhost 3000. So let's switch to the browser and open up localhost 3000. We see we're joining a call and we are now part of the call. We can even see the speaking indicators here. We can switch on the camera and you can see myself here. I can switch cameras, I can switch microphones, but basically this is what we have as a starter project. So we have this running, we have a video conferencing app where other people can join, but now we want to add the AI features next. So let's take a look at how we can do that, shall we?
The first AI feature we want to integrate is live transcriptions, and for this we can use AssemblyAI's streaming speech-to-text feature. We can use their Node SDK, which makes it really simple to implement this. So the first thing I want to do is add this as a dependency. In this case we are using Yarn, so I say yarn at AssemblyAI. And just a heads up, even if you can get a free API key and free credits, you still have to enter your payment details to access the streaming and LLM features of the API. So with that out of the way, let's write some code. And the first thing I want to do is to create some helper files. So let me copy this in here. You want to create a new folder helpers, and then in here, let's create 4 new files. Create microphone, create transcriber, get assembly token, and merge buffers. So let's start by implementing create microphone. So in create microphone, let's add a function create microphone that we export. This gets a media stream as an input, which we need to get later in the UI. And for this, I recommend checking out the Web Audio API. There, for example, you see the media stream and also the audio context is relevant for us. So I'm not going into too many details here. I recommend that you check out these resources. So let's start by writing this function. So first, let's create a few objects we need. We need an audio worklet node, an audio context, a source, and then a buffer queue. So basically an integer array where we want to store all the different incoming buffers. And then we want to return 2 functions here. So create microphone has start recording, and then later we add stop recording. Start recording gets an on audio callback. With this, we can send the buffer or the information back to the UI, and then we can show it later. So we get the audio on audio callback. Here we start by creating a audio context, and here we define the sample rate. This is important. We also need to define the same sample rate later when we create the real-time transcriber. So with our audio context, we can create a media stream source, and this is our source. Then we need to create an audio worklet node. So we create a new audio worklet node, and we also need to add this module. Then we need to connect everything, so the source to the audio worklet node and audio worklet node connect to the audio context destination. Then we define a callback, so we listen to the port, and then whenever there's an incoming message, we process this. And so this is where we get the incoming data from the microphone. And now basically we want to extract the data and store this in an integer array. This is our current buffer. Then here we have a helper function where we merge the current buffer with the audio buffer queue where we store everything. And we implement the merge buffers in a moment. So then we have the queue where we have all the incoming buffers stored. And with this, we can calculate the current buffer duration. So this is the audio buffer queue length divided by the sample rate times 1000, because we want to have this in milliseconds. And then we check if the buffer duration is longer than 100 milliseconds. Only then we want to send this to the server and then transcribe it. So if this is the case, we calculate the total number of samples. Then we create our final buffer. So this is the subarray starting from 0 until the total number of samples. Then we remove everything from the current audio buffer queue by creating the subarray. So we only keep remaining samples if there are any left, for example, through this rounding operation. And then this is the important line. So here, if we have an on-audio callback that we feed in from the outside, we call this and pass in the final buffer as information. And with this, we can handle it on the UI side. So this is the whole code in the start recording function. And the stop recording is pretty simple. So here for every track, we just call track.stop. Then we also want to close the context again, and we also want to reset the buffer queue. So this is all the code we need, and we also need to import and implement merge buffers. And to use this, we import merge buffers from merge buffers, and then inside of merge buffers, we create this little helper function, just a small helper function that merges the left-hand side with the right-hand side. So we create a new integer array with the new size, and then we set the left-hand side and the right-hand side and return this. So now we have create microphone implemented. Now we need to implement create transcriber. Here we start by importing the real-time transcriber and real-time transcript objects from the AssemblyAI Node SDK. We also import our helper function getAssemblyToken, which we implement in a moment. And in here we create and export one async function create transcriber. And it gets one function as an input, which we call transcription processed. And with this, we can pass in a transcription string and then a Boolean that basically indicates if the sentence is final, so if it is finished or still ongoing. And with this, we can then send the information back to the UI and then show this. And it will return one promise of a real-time transcriber. And then in here, the first thing we do is get our token with the helper function, and then we check if we have a token, otherwise we return immediately, and otherwise we can continue. And here we set up our real-time transcriber, where we have to define a sample rate, and this is required, and make sure to specify the same one that you used when setting up your microphone. You also have to pass in your token for the authentication, and then the next parameters are optional. So for example, you can specify a word boost to make sure certain words are better transcribed. You can also manually configure the threshold for when an end of a utterance or end of a sentence basically should be detected. In this case, after 1000 milliseconds of silence, we basically say this is the end of an utterance. And then if you're dealing with different encoding formats, make sure to specify the correct one here. So now with our transcriber, we can also define different callbacks where we subscribe to different events. So one is the open event. In this case, we simply log the session ID. Then in case of an error, we simply log this. As a to-do, you could do some error handling or cleaning up of the resources, but for simplification, we left this out here. The same for the close event. Here we simply log this. And then this is the important callback in case of a transcript event, which means we get a transcript from the streaming service back. Now we want to handle this. And first, again, some error checking. If the transcript text is empty, we do nothing here. Otherwise, we check the message type because there are two different types of transcript. a partial transcript, which means the sentence is still ongoing, or a final transcript in the else clause, which means the sentence was finished. And here in both cases, we call the transcription processed function and pass in the transcript text and then the corresponding Boolean false or true for is final. And this is all we have to do in this callback. And then in the end, we return transcriber. So this is the whole code of the create transcriber function. And now there's only the last helper function, get assembly token. So let's open this and then let me paste this in here for you. This is all that we need. We export one async function, get assembly token, which will return a string with a token. Here we call fetch, and then here we fetch the internal Next.js route that will be located at /API/assembly token. And we also have to define this route in a moment. And this will be a post method with the content type application JSON as headers. And then this is also important so that it works properly in Next.js. Make sure to specify cache, no store. And then we can await the response and get the JSON. And then from the JSON, we can get the token field and then return this. So this is all that we need here. And now we have to define this Next.js route to send the external API request. So let's create this route. So we have to go into app API. And there we already have one route to get the stream token. So in here, we have to create a new folder. So I copy pasted this in here, a new folder assembly token. And then in here, another route TS file. And in here, we import the assembly client, AssemblyAI client. Then we export one async function post. In here, we get the API key from the environment variable and check if we have one. And then we can create our assembly client with the API key. And then we can call await assembly client.realtime.create temporary token. We can also specify when this token should expire. And this way we get a token and can then safely authenticate on the client side. Then we put this into a object with the token field, and then we return this in JSON format. And then again, we can extract this here and return this on the client. And now we have all the helper functions in place, so I can hand it back to Stefan, who can display this in the UI.
Thanks, Patrick. We added the logic for transcriptions now and the calls to the AssemblyAI backend, but what's still missing is the UI integration, so we won't see anything yet. So let's jump into VS Code and let's open up the call layout file, which has the logic for showing the participants, the speaker layout, and the call controls. So we will gradually fill this up with more information to display the transcribed sentences now. For this, we first start off by importing the use callback and use state hooks from React because we will need them in a second. And then to show transcribed text, we have a state variable here called transcribed text that we initialize as an empty string. And then we have a robot active variable that will display whether or not transcriptions are currently active. So we want to have a button that can activate transcriptions and deactivate them. Then we also need a transcriber, of course, because we need to have an object for this. This is going to be a real-time transcriber, which we import from the AssemblyAI package. And then finally, we need a microphone that is able to start and stop recording so that we can take what was said and feed this into the transcriber that we will have. Now, first, we want to show something here, and we import the image component from Next.js as well as the robot image. I mean, I can show you this. This is a simple robot image that I got from the web. So we want to display this and allow the user to click on this image to activate transcriptions. To do this, below the call controls, we add a new button that on click calls a switch robot function, and we display the image here of robot image. And for styling, we give it some slide border and a transition. And if the robot is active, we add the pulse animation to it so that we have some indication that transcriptions are currently active. Now we're still missing the switch robot function, so let's add this next. And first we check if the transcription is currently active. If yes, we want to deactivate it. So we say we want to stop recording on the microphone. We want to actually close the transcriber that we have and then set the mic and transcriber to undefined and the robot active to be false. However, if the robot is currently not active, then we want to initialize AssemblyAI because we haven't done that yet. And then we want to set the robot active to be true. Now we haven't defined the initialize AssemblyAI function yet. So let's do this now. So let's define this function here. We call it initialize AssemblyAI and wrap it in a use callback hook. It's going to be async. And we first create a transcriber. So we want to call the create transcriber function and hand in the transcription processed function that we haven't defined yet. So for this to work, we need access to a few things. We need access to a microphone, of course. And we need access to the create transcriber function. So let's import the create transcriber as well as the create microphone functions that Patrick defined earlier. And after that, we can create a new transcription processed function, again wrapped inside a use callback hook, with a text set as well as a final boolean that we will use later on when we integrate the LLM. And then we simply update that set transcribed text state variable that we defined above here to be the new transcribed text. We need to make this dependency available in the use callback hook here because whenever this changes, it needs to be recalculated. And then we say if the transcriber is not created correctly, then we will show an error because then things cannot go forward here. And then we connect the transcriber. So we call the connect function on the real-time transcriber object. Next, we import the use microphone state hook from the use call state hooks because we want to access the microphone now. And we use this to extract the media stream from the microphone. So this is actually what we can use to process the audio. We say if the media stream is not there, we can't proceed. And we add the dependency, of course. And then we create the microphone. Remember, we imported this function at the top here. So we can now have the microphone. And then we call the start recording function on the microphone and send the audio data that we get to the transcriber that we just defined. With that, it can process the audio and return the results that it extracts to us. Then we set the mic. And we set the transcriber. Then we set the mic as the variable that we have, and we set the transcriber as well. Now, the processing happens now, but actually we're not displaying this yet. So let's jump here, and next to the speaker layout, we want to display the transcriptions at the bottom of the video feed. So let's add a div here. And we want to center everything inside and give it an absolute positioning with a slight bottom margin. Inside we create an H3 with a white text and a black rounded background and some padding. And here we simply want to display the transcribed text, which is the state variable that will be updated whenever the transcriber transcribes new text. And once we have saved, we can jump into the browser and refresh here. And you can see we're still able to see the call. We can activate the video, but we don't see any transcriptions yet. So I activate the transcriber now, and we can see already that now transcriptions are working. It shows us the transcriptions while I speak, and it updates them, and I can even deactivate this, and it stops with the transcription. So the setup worked, which is a great success. So we hooked up the UI with the logic that Patrick already implemented, and everything works quite flawlessly. So with that, we can now jump to integrating the logic for the LLM. And for that, I will hand it back to Patrick again.
To integrate the LLM, we use AssemblyAI's Lemur framework. Lemur makes it super simple to apply LLMs to audio data. It only takes one API call. And to do this API call, we need to define a new route. So inside app API, let's create a new directory Lemur request. And then inside this directory, create a new route TS file. And here we can implement this route. So let's start again by importing the AssemblyAI package, and then we export another async function post. This time we can send in a request parameter. Then here again we get our API key and do some error checking and then set up the AssemblyAI client. And then we get the JSON data from the request, and this JSON data should contain one prompt field. And this is the prompt from the user. For example, when the user says, "Hey Llama, what are the action items from this meeting?" then this question should be stored inside this prompt. And then we do some error checking. So if there is no prompt, we return an error. And otherwise, we do a little bit of prompt engineering. So we give a little bit of context. So we say, you act as an assistant during a video call. You get a question and I want you to answer it directly without repeating it. If you don't know the answer, clearly state that. And here is the user question, and then we append this here. So this is how we build our final prompt. And then we can call client lemur task. The task is a very flexible endpoint where we can feed in any prompt. So we specify our prompt. So this is our final prompt here. And then we can also specify a little bit more input text, so some more context. So for now, we simply say this is a conversation during a video call, but later we want to feed in the actual meeting text. So the whole transcribed text will be put in here as additional context for the LLM assistant. So for now, we simply have this. And then when we get the lemur response back, we put this into a object with the prompt field and the response field. And then we return this as JSON. So this is the whole request we have to do inside of this function. And now we can call this function, but we also need to know when we want to call this function. So basically, we want to have a trigger word. So whenever the user says during the meeting, "Hey, Llama," and then whatever comes next is the question. So, "Hey, Llama, what are the action items?" Then we want to call this post function here, and the question, "What are the action items?" is the prompt from the user that will end up here, and then will also end up in the final prompt. So now we have to check, when does the user say, "Hey, Llama?" So we need to set up a trigger word. And for this, we need to do a few small changes in the create transcriber function. So in here, whenever we have a final transcript, so in the else clause, whenever the sentence is finished, we want to check if the sentence contains the trigger word. And we can do this with a simple if check. So if the transcript text converted to lowercase has index of llama is greater than 0. So this is how we check if the string contains this trigger word, and we hardcode this here. And if so, then we want to call this new function process prompt, and the prompt will be the transcribed text. So this is the first thing we want to do. And then we also want to change the state of the llama. So for this, or the state of the assistant. So for this, we do the same check here and then call the second new function, set llama active. And then in here, this will be a Boolean either true or false, depending on if the trigger word is contained inside the string. So we have these two new functions, and we can define them in the create transcriber parameters. So here we add them, and the process prompt is a simple function that takes a string as an input, and setLlama_active is a dispatch with a set state action. So basically on the outside it will change a React use state hook. So we also need to import this. So we have the types. And yeah, these are all the changes we need in here. And now on the UI side, we can now handle the process prompt and the setLlama_active functions. So with that, back to Stefan.
The logic is there. So again, we need to hook up the UI in order to actually use this somewhere. And this is where the fun starts. So let's directly jump into the call layout again. And here we first add two state variables here. First, whether the LLM is currently active or not. And then we want to also have a state variable for the response of the LLM. It's inactive by default, and the response is empty at the beginning. But we can already see we have an error here. So our create transcriber function now expects 3 arguments. This is the transcription processed, the setLlama_active, and the process prompt functions that we need to add. So let's first define the function for the process prompt. We wrap it in a use callback hook, and the prompt will be input as a string. And then we call the route that Patrick just defined, so the lemur request route, and we make it a post request, and we enter the prompt as a parameter here, and we get the response back. We take the response from the response body, which is going to be the lemur response that we actually get from the LLM. We log this just to see if things work, and then we set the LLM response after receiving it, which is just simply calling the API that was just defined by Patrick. With that, the LLM response gets displayed, but for this, we actually want to hide it again after a certain time. So let's add another function here called setTimeout, which means we can wait for 7 seconds and then execute different code. In our case, we set the LLM response to be empty again, the LLM_active to be false, and the transcribed text to be empty. With that, we basically reset everything after 7 seconds, and then we can wait for new requests coming in. So with that, we can add the LLM_active, which is going to be updating our state property, as well as the process prompt parameters to the create transcriber. We also need to add it as the dependency in the use callback hook. And with that, the logic is already in place, so it doesn't require much logic adoption, but we need to update the UI for this. So let's scroll down here, and we can now create a new div here. And for this, we give it an absolute positioning. We want to animate the transition here, and specifically want to translate it, so update the positioning in the X and Y axis, as well as animate the opacity. So when the LLM is active, we animate this container in. If it's inactive, we animate it out. And for this, we use an image, which we import, the llama image, which is already part of the repository. And we simply display this here. Now we are displaying this when there is an active request to the LLM, but we're not yet displaying the response we get from the LLM. So let's add another div for this. We check if the response is actually a string, so if it's not empty. Then we create a div container here, give it an absolute positioning and some padding again. And then inside we simply want to display the LLM response. So we can save and switch to the browser. We refresh the page and we can activate the LLM again, wait for it to pulsate. Now the transcription is active and I can now trigger the LLM. Hey Llama, what is the capital of Italy? we see it's depicted on the top right here. So everything works as expected and it disappears after 7 seconds. So this worked great. We finished asking the LLM questions, the LLM response, but now I already promised you that we want to add one more feature, and that is to add the history of what was said during the meeting to the prompt that we sent to LLM, so we can ask questions that were previously explained in the meeting. So let's do this now. Now we want to add the history of what was said during the current meeting as a context for our LLM to be able to process this information as well. For that, we need to do two things. We need to somehow save the transcription of everything that was said before. So we don't only want to display this, but save it somewhere. And second, we need to add this to the Lemur request that we're sending away to the AssemblyAI backend and add this as a prompt and add the context to this prompt. So first, let's start by adding this to our call layout here. And the implementation is actually quite easy because first we create a full transcription ref object. We import the use ref hook from React for this. And what this is it is an array of strings that we initialize as an empty array. Now we need to fill up this array of strings with all of the sentences and all of the speech that was said. And a good place for this is our transcription processed function, because we can say if one transcription piece was finally finished processing, then we say if is final is true, then we add to the current full transcription ref the new text. So we append this to the end of everything that was said before. And now the only thing remaining is that we don't only want to send the prompt to the LLM, so the Lemur request, but we also want to add a transcript. And for that, we combine everything that was said. So all the strings that we have in our full transcription ref object, we join them with empty spaces between them into a single string. And then we add this as a full transcription property here and add the combined transcript. So with that, we're sending all the necessary information to the Lemur request. So what remains for us to do is to actually change this request to process this information. So for that, I have to touch Patrick's code here that he created in the Lemur request route. And what we're doing here is we're extracting the prompt from the body. And here we just added the new parameter so we can extract the full transcript here as well. We can log this just to see if everything works. And then we have the final prompt here that we put together for our LLM. And now we want to add context to this. So we can add a input text here to the Lemur task combined with the final prompt. And for that, we need to first give it the context of what are we actually handing here towards the LLM. And we say this is a conversation during a video call. Here is the history of the call so far. And we add the full transcript here. And this is actually it. So with that, we add the memory of the meeting to the LLM's knowledge. And it can now process the information that we have discussed during the meeting. So let's see how this works in action. We switch to the browser. We now want to activate the LLM again. And now we need to say a few things so that we know if the LLM can actually process that. The next version of the product is going to be version 3. The next version of the product is going to be released on December 21. The most important features include a new dashboard, an updated authentication flow, and new UI elements. Hey Llama, what is the next version of the product? Hey Llama, when is the next version going to be released? Hey Llama, what are the most important features of the new launch? I know that this was a kind of constructed meeting history now, but I think it's quite impressive to see how accurate it can answer the questions, given that we just hand in the context of what was previously said. So I think this was a really cool demo of a really powerful feature that we have built in a very fast and easy way. Awesome job. In this video, we have built a pretty cool application that is an AI-driven conferencing app that adds some really nice LLM-powered features to it and a cool live transcription service as well. I think it's really cool to see what happens when we combine really powerful services such as the video calling features from Stream combined with the transcription and LLM capabilities that AssemblyAI offers. The product that we have built is quite useful and adds real value to end users with the capabilities that we've implemented. We hope you were inspired to build something on your own and can see how fast and easy it is to build with these products. So let us know what you are building with it. Don't forget to like the video and subscribe to the channel. And we would love to hear from you what cool things you are building in the comments. Have a great rest of your day. Bye.